Hey everyone, and welcome back to the deep dive. Today we're really digging into VMware Cloud Foundation VCF. It's such a foundational piece of modern IT infrastructure, and we're going to try and break down some key concepts, stuff that's super important, especially maybe if you're looking at that 2V0-13.25 exam. So our goal here really is to pull out those crucial insights, help you get a solid grasp quickly on VCF design, its core parts, and those operational bits. Think of it like a shortcut, maybe, to understanding VCF without getting totally bogged down in, endless documentation. And yeah, speaking of the exam, our sources give some helpful context. It's 64 questions. You get 130 minutes. Passing score is 300 out of 500. And you'll see a mix, like multiple choice, multi-select, drag and drop. Oh, and the fee, usually around $250 US. Okay, so let's unpack this. Let's explore how these VCF ideas actually, translate into real IT infrastructure that works. Let's kick things off thinking about design.
Right. So say an architect's building a VCF solution and the business, they need like a 99.99% uptime guarantee.
What's the number one design principle that has to be absolutely front and center there, and why that one specifically?
Right.
That 99.99% target, it immediately screams availability. What's fascinating, I think, is that it's not just adding redundant kit, not just hardware. It's about meticulously designing for fault tolerance.
Yep.
Robust failover mechanisms, resilient processes, true 99.99% availability. It goes way beyond just having backups. You have to anticipate failure points in software, networking, even like operational procedures. Often the biggest challenges pop up in overlooked dependencies or just plain human error, that can take down systems that look highly available on paper. So it's a really comprehensive way to make sure services stay up with minimal downtime. Very different from, say, recoverability. That's more about bouncing back after something breaks.
Right. It's the whole picture, not just one piece that really hits home. So building on that, let's pivot to security. Always huge. Imagine a customer, they need VCF, but it has to integrate with their existing physical security stuff. And this is key, a third-party identity system. What kind of requirement is that? And well, why is that integration so critical? Oh yeah, that's a clear-cut security requirement, no question. Needing to hook into identity management and use existing physical security, it's not just like an optional extra, it's fundamental. And this brings up a really important point. Just how deeply security needs to be woven into modern infrastructure design right from the start. Identity management, for instance, that's your absolute front line. Who gets access to what? So integrating that properly is just paramount for control, for audits. Totally different from, say, a performance requirement that'd be about speed, or a business one, which might be, broader goals.
Got it. So embedding security from day one, not just trying to tack it on later. Makes sense. Okay, so we've talked design principles. Now let's get into the actual building blocks, the components that make these designs real. Let's zoom in on the specific VCF parts, starting with networking. What's the key role of the vSphere distributed switch, the VDS, in a VCF setup?
Okay, the VDS, its crucial role is basically to simplify network management. It gives you a consistent configuration across all the hosts in a cluster. And that's incredibly powerful, right? Because it centralizes and standardizes the whole network setup, ensures everything's uniform, cuts down significantly on human error, especially when you're dealing with big, complex VCF environments. Think of it like having one master control for all your network connections instead of fiddling with each host one by one. It's not about like orchestrating VCF itself or storage. It's really about building that consistent, solid network fabric.
Yeah, I can see how that would save admins a ton of headaches. Consistency across the board, definitely key. Okay, speaking of orchestration, let's talk about the brain of VCF, maybe.
Yeah.
Which component is specifically responsible for automating the whole end-to-end deployment when you want a new workload domain?
That would be the amazing power of the SDDC manager. That component, it really is the automation engine for VCF. It handles the whole lifecycle deployment configuration, updates for workload domains, start to finish. And here's where it gets really interesting when you realize just how much automation VCF gives you. I mean, imagine going from potentially days of manual setup and, troubleshooting for a new domain to essentially clicking a button.
Wow.
Yeah. While, NSXT handles networking and vCenter manages the clusters, only SDDC Manager does that big picture orchestration for the workload domains. It's just a massive leap in efficiency.
That is a huge game. Absolutely changes how IT ops works. Okay, storage. Always a hot topic, right?
Right.
Especially performance. So let's say an admin's troubleshooting. VM performance is sluggish. They suspect storage. Which VCF component is providing that underlying shared storage layer they're looking at?
Right. The significance there points directly to vSAN, is the software-defined storage solution that's built right into VCF. And what's kind of revolutionary about it is it takes the local disks, from all your servers, your hosts, and pools them together. Creates one big shared data store for all your virtual machines. This means you're using standard server hardware for storage. Gives you huge flexibility, scalability, and often, big cost advantages compared to those traditional external storage boxes. It's a really core piece of that whole hyperconverged idea within VCF.
That integrated software-defined approach.
Yeah, sounds incredibly powerful. Okay, one more component, back to networking, but with that security angle, what's a primary benefit of using NSXT for east-west traffic, traffic within the data center?
The main benefit there is that NSXT simplifies creating and managing virtual firewalls for microsegmentation. And honestly, this is a total game changer for security.
Instead of just having like a strong wall around your whole data center, NSXT lets you put granular internal firewalls around individual VMs or applications. So this stops threats moving sideways inside your data center. If one system gets compromised, the threat can't easily jump to others. It fundamentally changes your security posture. Gives you really deep internal defense. Much better than just a perimeter.
That's a huge shift, moving from just a hard shell to these tiny internal defenses. Very cool. Okay, so we've kind of dissected the individual gears and levers of VCF. It's fascinating, right? How each bit has such a specific vital role. But how do they all combine, to form the bigger VCF picture, especially for orgs needing to split up resources or manage complex life cycles? Let's broaden the view now. Talk architecture and maybe the day-to-day operational side. First up, architectural design. Say an organization needs a VCF design where different departments get their own isolated pools of resources, and crucially, separate management. Which VCF concept handles that?
That scenario perfectly describes why you'd use workload domains. They provide that logical isolation. Dedicated resource pools, and really importantly, separate management planes. Makes them absolutely ideal for multi-department setups or even multi-tenant environments where you need that strict separation.
Okay.
Think of workload domains like self-contained apartments in a bigger building.
Right.
Each apartment has its own stuff, its own management, even though they share the same foundation, the building itself. And if we connect this to the bigger picture, this is how large organizations can really effectively segment their infrastructure within one single VCF deployment. It goes way beyond what simple resource pools or just vSphere clusters alone can offer, management-wise.
So it's more than just resource isolation. It's that whole management separation, like mini VCFs inside VCF.
Yeah.
I can see how that'd be a massive win for compliance, multi-tenancy stuff. Definitely. Okay, shifting gears to lifecycle management, especially prepping for big updates. During that VCF lifecycle process, which step is specifically about making sure the whole environment is in a known good state before you kick off a major update?
Yeah, that's where we talk about the absolute importance of pre-check validation.
Yeah.
This step runs before you even think about starting a major update. It meticulously checks system health, looks for dependencies, verifies everything's ready. It's purely proactive, designed specifically to prevent failures during the upgrade, catching potential problems before they turn into big, costly headaches. Totally different from, say, just taking a snapshot or relying on a manual rollback. Those are reactive, right? Recovery actions after something's already gone wrong. This is all about prevention.
That sounds like an absolute lifesaver, especially with complex systems, Okay, let's talk capacity planning for a sec. A VCF architect, they're planning capacity for a new workload domain. What's the most important metric when they're figuring out how much compute resource they need?
Well, when you boil it down, capacity planning is fundamentally driven by the total number of CPUs and the amount of memory needed by the virtual machines you plan to run.
Okay.
Sure, other things matter, like how many physical hosts you have, the vSAN version maybe, licensing costs. Those are constraints, definitely important considerations.
Right.
But the actual workload requirements, what your applications, your VMs, actually need to run, well, that's the primary driver for figuring out compute resources. Get that wrong. You either end up spending way too much on hardware you don't need, or you hit critical performance bottlenecks later. So knowing your real workload demand is just paramount.
That's a crucial point. Start with what the apps actually need.
Got it. And finally, let's wrap up this operational bit with something really practical. Post-deployment tasks. So, you've deployed a shiny new VCF workload domain. What's a key operational task an admin has to do next?
Okay, so once that domain is up and running, the key practical next step for the admin is creating the virtual machines and then configuring their networking and storage. Remember, VCF automates a huge amount of that initial heavy lifting, like Installing ESXi manually, the whole bring-up process, connecting vCenter manually,
Yeah.
that's all handled.
Like the automation piece.
Exactly. So for an administrator's day-to-day work, after that initial setup magic, VM provisioning and configuration, that becomes the critical post-deployment focus. So what does this all mean for their daily job? Well, their focus shifts, right? From building the plumbing from scratch to actually delivering services on top of it, directly to their users.
Thinking about this balance, between all this automated deployment VCF offers and the ongoing operational tasks, what new challenges or maybe even opportunities might pop up for IT pros? The folks responsible for actually maintaining these advanced infrastructures day in, day out, something to think about.